Hi everyone! So in this video, we're going to go ahead and talk about periodic table trends, which are characteristics of elements that have a unique pattern that we can predict as we go either down a group or across a period. So let's go ahead and get started. Okay, so this first thing is really important. I want you to spend extra time, make sure you really understand it. If you have any questions, please let me know. But the really key thing to understand is something called the octet rule, because we'll be using this for pretty much the rest of our chemistry unit. So the octet rule tells us that main group elements, so this is everything that's on the left-hand side and the right-hand side. So basically, we ignore the bottom two rows and the transition metals. So the main group elements want to have full valence shells, meaning that their outer ring needs to be filled up to the maximum amount, because this makes atoms more stable, and that's a good thing. Now, for most atoms, this means they need 8 valence electrons. That's where the name octet comes from. So octet means 8, so the octet rule is the rule of 8. So some atoms either need to gain or lose electrons in order to get to that magical number of 8. If we think about it, though, the noble gases, they already have a full outer shell. They're stable. That's why they don't form bonds very easily. Now, one little side note, some very small atoms like hydrogen, helium, even lithium, they're too small to have 8 valence electrons because they just don't have enough protons. So because of this, they go to their inner shell, the smallest one, which only holds 2 valence electrons. So they're satisfied with just 2 valence electrons, even though the octet rule usually wants 8. Okay, so if we look back at that Bohr diagram, just a quick reminder, that inner ring only has 2 valence electrons. That's for really small atoms. They're satisfied with the 2. But our bigger atoms, they're going to have 8 valence electrons. Remember, 8 octet. Okay, so one trend we have is atomic radius, which is basically the size of the atoms. An atomic radius is 1/2 the distance between two nuclei. So it's really hard to measure the size of atoms because the outside part of the atom is the electron cloud, and it's hard to measure a cloud. So what we do instead is we take 2 identical atoms, so 2 hydrogen atoms in our picture, and we're going to squash them as close together as they're going to go. And then we measure from one nucleus to the next nucleus. The reason why we use the nuclei for our measuring is that that's a very dense part of the atom, so it's easier to detect than the electron cloud edge. So we measure from one nucleus to the next. We take that distance divided by 2, and that tells us the radius or the size of an atom. So atomic radii increase as you go down a group, and they decrease as you go across a period from left to right. So that's one correction to make in your notes. There's a typo. They decrease as you go across a period, not across a group. So atomic radii, as you go from top to bottom, they're going to get bigger, and then as you go from left to right, they get smaller. So actually the largest atom on the periodic table is going to be francium in that bottom left-hand corner. And according to the trends with atomic radius, we expect that helium, the top right, is going to be the smallest. Okay, so you're probably wondering, why is this the case? Well, as we go down each period, remember that we're adding extra rings or extra energy levels. The first period, we have 1 ring. Second period, we have 2 rings. Third period, we have 3 rings. Each of those rings or each of those additional energy levels takes up more space, and it pushes the electrons further away from the nucleus. Now, as we go across a period, the atomic radius decreases, and this one's a little counterintuitive, but if you stop to think about the science, it does make sense. So as we go across a period from the left-hand side to the right-hand side, we are adding more protons, neutrons, and electrons. So normally, things get bigger. However, the electrons all get put into that same ring, that same energy level. Meanwhile, we keep adding more and more protons. And we know that opposites attract. The positive protons are going to attract the negative electrons. They want to come closer together. And as we add more protons to the nucleus, it's like adding an extra rubber band. It kind of sucks everything in a little bit tighter, a little bit closer to the nucleus because there's more attraction. So as we go across from left to right, the atoms get a little bit smaller. As we go down from top to bottom, they get a little bit bigger. Okay, so another trend we have is something called electronegativity, and this has to do when atoms form bonds. So electronegativity is the ability of an atom to attract electrons to itself when it's in a chemical bond. So basically, it's the idea of how well do atoms share. Do they share really nice and have it nice and equal, or are they greedy and pull the electrons closer to them? If they're greedy, they pull the electrons closer, they're more electronegative. So electronegativity increases as you go up a group and as you go across a period from left to right. So fluorine is the most electronegative element on the periodic table. Make sure you memorize that. It's a really important fact. The noble gases do not have electronegativity values because they do not form chemical bonds, so we ignore those, but fluorine is the most electronegative element. Francium has a very low electronegativity because it's far away. Okay, so for reactivity, we actually have two different trends depending upon if you have metals or nonmetals. And reactivity is describing how likely an atom is to form a bond with another atom. So for metals, the reactivity increases as you go down a group. This is because it becomes easier for them to lose electrons. I kind of think about it as these really big metals. It's kind of like when you go shopping and you're carrying a ton of bags from going shopping. You have 10 different bags. It's very likely you're going to drop something if you have a bunch of shopping bags because you're trying to juggle so much. So it's easy for them to lose electrons because they're trying to keep hold of a whole bunch of electrons. Nonmetals on the other hand, their reactivity increases as you go up the periodic table. So fluorine is very reactive. This is because it's easier for the atoms to accept electrons from their neighbors because they're not holding on to as much stuff. So when they take an electron, they can hold on to it easily. Okay, so thanks for watching. If you have any questions, please let me know. Otherwise, have a great day, everyone. Bye.